Hello, welcome to my note session on the new Cypher project in Neo4j Graph Data Science. My name is Paul. I work at Neo4j on the Graph Data Science team, or GDS for short. And GDS itself is a plugin for Neo4j that provides implementations of graph algorithms and machine learning capabilities to Neo4j. This session is not an introduction to Neo4j to GDS. So I'm going to assume you're at least familiar with the basics on how GDS operates here. That said, one core aspect of GDS is that we don't operate directly on the Neo4j data. Instead, we project the data that we want to use into an in-memory graph catalog, and then you can run your algorithms and ML pipelines and stuff on the graphs in the catalog. And one such projection method is the Cypher projection, which used to look like this. So there's a procedure call. This is a Cypher query here. There's a procedure call to gds.graph.project.cypher with a couple of arguments. We have persons, the name of the graph in the catalog. And then there are two Cypher queries, one for nodes and one for relationships. In this example, we have a person knows person graph. Doesn't really matter what the actual data is. It's just an example here. This kind of projection comes with a few usability problems. For one, the projection query itself is a string. It's not really Cypher. It's a string that happened to contain Cypher, as we can see here also with the syntax highlighting, which makes it a little bit more difficult for tooling to understand. And also, if you're doing strings within your query, you have to do additional escaping and so on. The other thing is that you have two separate queries for nodes and relationships. And if you do a lot of work, not just the simple like match n with a label, if you do a lot of work to project your nodes, you kind of need to figure out to do the same work for relationships again, or figure out how to somehow cache the results for the nodes. It's not really that great. So we went out and tried to improve the Cypher projection, and this is what it now looks like. You have a regular Cypher query. It's no longer a procedure. You start with a match statement or something else that produces a set of source and target node pairs. And then you basically aggregate them into a graph. So in Cypher, you have these aggregation functions where in certain positions, you can do something like count or sum to aggregate all your rows into a single value. And the new Cypher projection is basically you aggregate your stream of source and target node pairs into a graph. So here we have the match, and then in the return position, there's a call to the gds.graph.project aggregation. You have the same persons for the graph, and then you have your n and m, which are your source and target nodes. This new projection had first been introduced in GDS 2.0, back then in the alpha tier and under the name Cypher aggregation. With 2.4, GDS 2.4, we promoted it to production tier, improved the API a little bit, and it's now the projection, the method that we talk about when we say Cypher projection. The previously existing Cypher projection I showed earlier on the slide, that one has been renamed to legacy Cypher projection and is also deprecated since 2.4. Now, not all queries will look as simple as just a match and then you're done. Usually you want to have additional data in your graph, such as node label, relationship type information, properties, and so on. So here's an example of a projection of a graph with multiple node labels and relationship types. And in order to get that into the GDS graph, we add another configuration map here. So we have our graph name, source and target node, and then we have a map where we configure details for this particular projection. So here we have a source node label and a target node label to specify the labels for source and target node respectively, and also relationship type configuration key for the relationship type information. You can use any kind of means to produce the values, a list of string for labels or a string for the type. You don't have to use labels, leave the function labels and the function type. But using this means that we get the data from Neo4j and we have the same data in the GDS graph. You might have noticed that the node information has to be provided twice, once for source nodes and once for target nodes. And the reason is that we cannot really be sure that the query is written in a way that all nodes always appear in the source node position. In fact, if we look back at the query and think about what this actually represents, like a book knows a person, doesn't really make sense. It's more likely that a node with a book label will only appear in the target node position. So by providing the same information for source and target nodes respectively, we can be sure that we see all the data for all the nodes regardless on how the query matches them. Projecting properties look similar like this. In this example here, we want to project the age property from nodes and the since property from relationships. We can use a map projection syntax to create a property map. This is this one here. So the age property value is read from the source node and projected as a new map into a new map under the same key age. And we use a Cypher map to specify all the properties that we want to have for as well source node and target nodes. The same is true for the relationship properties. Usually you want to also have the source node labels and target node labels and relationship type keys here in this configuration map. It's the same configuration map. I omitted them here on the slide so that examples fit on this slide. Unlike Neo4j, GDS has a fixed schema. So you might have to provide default values for your projection in order to fit the data into your schema. And you can use Cypher itself to do that. So here we are using, in a separate with clause, we're using the coalesce function, and we are providing a default value for age. So we match again on nodes that are either a person or book. And we assume that book nodes don't have the age property, but we need to provide the same schema for GDS. So we are saying if the age property doesn't exist, we use 18 as a default value. Whether or not that makes sense is besides the point here. And here we also see that we don't use a map projection anymore. We just provide the map itself because we created the values in the with clause. Then GDS has a concept of graph orientation. And the graph can be natural, undirected, or to most typical orientations. And when using a Cypher projection as shown here, you'll always end up with a graph in the natural orientation. Even if you change the match, if you change the arrow here, if you remove it to say I want to match in both directions, in GDS the graph will still be in a natural orientation. And that is, we assume that these N and M, the source and target node pairs, they are representing a directed relationship from source to target. And we have no insight into like what you actually do, what you match, so we don't know whether or not there you have a outgoing or incoming or both direction there. So we're just saying, okay, whatever you give us is representing a direction from source to target. Now, some algorithms in GDS, they require an undirected graph, or they would benefit from an undirected graph, or work slightly different with an undirected graph. And so in order to project such a graph, you can have an additional configuration map, a second map, where you can list all the relationship types that you want to have projected as undirected. It's a second configuration map because the first one is for each individual row for the source and target node pairs, whereas the second map is for the whole projection itself. So you cannot say on each single relationship whether or not that should be undirected or not. You declare it on the relationship type level. And you also don't need to change the match here to match in both directions. GDS will do this internally for the undirected types. Another thing of note is that we can also specifically project disconnected nodes. This is something that incidentally happened with the legacy Cypher projection. So if you remember, you had a separate queries for nodes and relationships. And that means we would add all the nodes from the node query, but we don't really check whether or not they're connected because the relationship query runs later. Unless you went through the effort on writing the query in such a way, you would by default get disconnected nodes. With the new Cypher projection, this is the other way around. If you're using a match and nothing else, you will only project connected nodes. And if you do want to have disconnected nodes as well, you can, for example, use something like an optional match. And in this example here, n is always a node, but if n is a disconnected node, there is no relationship, no nodes to another node relationship. So m might be null, and the Cypher projection allows null for target nodes, in which case the source node will be added as a disconnected node. The source node itself, so must never be null. Then I mentioned earlier that the values for node labels, relationship types, and so on, they don't have to necessarily come from Neo4j. You can provide any kind of values to produce the information. And this is also true, in fact, for the source and target nodes. I've always shown the match on the Neo4j node and then using the nodes for that. But you can also use arbitrary IDs, that is integer typed in Cypher, for your source and target nodes. And this allows you to essentially project any kind of external data source directly into GDS without adding it to Neo4j itself first, if you only want to use it for GDS use case. So here, I imagine you have a product CSV with some columns, and you can use load CSV. And you might have, you can say, I want to have my source node is the whatever the value is in the column supplier ID. My target node is the product ID. You can make up labels in a type, and that basically projects a supplier-supplied product graph directly into the GDS without this data having seen the inside of a Neo4j database. If you do that, however, we will disable the write execution mode for algorithms on that graph. The write mode is execution mode for algorithms that will write the result of that particular algorithm back to Neo4j, to the nodes that were originally projected into the graph. Since the data is likely not coming from Neo4j, but from somewhere else, it doesn't make sense to allow you to write to some Neo4j nodes. So we're just going to block all the write execution modes for these kind of graphs. You can use other ways to get the data. There's stream node properties. You can export the graph into a new Neo4j database. All that is fine. It is just for arbitrary IDs. We disabled the direct write back. We've also integrated this new Cypher projection into the GDS Python client. So this example here is Python code. It's no longer Cypher. And GDS is the instance of our Python client. And you can call gds.graph.cypher.project and give it the Cypher query that you want to run. It is essentially a wrapper around the run Cypher method, where you can run arbitrary Cypher and you get the result from that, except that we verify that the query ends in a call to return gds.graph.project. And we don't return the Cypher result, we return a graph object. So you can use it in the same workflow as other projections, where you get the graph and then G here, and then you can use that one. If you attended Ponder's session earlier, or in fact the keynote, there's a parallel runtime for Cypher, and the new Cypher projection is also compatible with that runtime. So if you prefix your query with this Cypher runtime equals parallel, you can benefit from a parallel projection. That can be quite faster than using the default runtime. So to summarize, since GDS 2.4, we have a new Cypher projection. Cypher first, and therefore integrates better into the Cypher ecosystem and makes better use of general improvements on Cypher runtime or runtimes. We have further documentation there. These are links to our GDS documentation, a general documentation link. We also have migration guides for moving from the legacy projection to a new one, as well as migrating from the alpha Cypher aggregation to the new one. And that concludes the session. Thank you, goodbye, and enjoy the rest of Notes.